Welcome to the third part of our 6.7 section here for our videos. We're going to have a couple more examples here. So my first example, population of a city is 30,000 people and a city grows by 7.8% each year. Write the exponential function and estimate the population in 5 years to the nearest person. So this is very similar to our future value formula for compounding. How is it the same? Well, there's a growth rate, 7.8%. That's my yearly rate. The one thing you notice is that it doesn't tell you how many compounds. So the 1, that represents 100%, and the ends will be a 1. And so what's going to happen to my base is it's going to become 1 plus the rate, r over 1. So that's going to be my base. So then they alter the formula. It's still based on the same thing. It's just that we put a capital B here, and that can be 1 plus a rate. Now, if something was not growing, it was decreasing, we would put 1 minus the rate, and that would be our new base value. So here, A, our initial value, just like your initial investment or your principal, is 30,000. And here's my rate, R. Again, remember, got to change it to a decimal, so 0.078. And we plug that into our formula. And if you want to simplify this, we can call that 1.078 on the inside. And then we now can answer the second part of the question. What's the population in 5 years? We just plug in a 5 for t, go to our calculator. We get 43,673.2. So to the nearest person, 43,673. The next example, the half-life of radium-220 is 2,150 years. A sample contains 500 grams. How much is left in 3,000 years? And how long until there's 100 grams left? So again, we could approach this in the same fashion. Here, a half-life, that means you're cutting everything in half. That's your base. So easy money. The next thing we have to understand, though, is your half-life occurs every 2,150 years. So what you'll notice in the formula is they call that P. That is the period length of the half-life. So we substitute these in. My base 1/2, now my time has to be divided by the period length. So let's put in our values. 500 grams is your beginning balance or initial amount, so that's your A. And 2,150 will go in for P. So here's my formula. So now how much is left in 3,000 years? We'll put 3,000 in for T. Well, it's definitely bigger than 2,150, so this answer has to be less than 250 because half of 500 is 250. However, we don't get 2 half-lives occurring. That means we would have to be, let's see, if we doubled this denominator, 4,300. Well, we're less than that. So if you take half of 500, which is 250, half of 250 is 125, your answer has to be somewhere between 125 and 250. So let's plug in the 3,000. Let's go to our calculator and enter this all in. 500 times 1/2 raised to 3,000 over 2,150 gives us 190.07 grams. So I'm just going to say, okay, approximately 190 grams. Now, don't get me wrong. You could put 0.5 there instead of a half. Up here, if you wanted to simplify it, you could just cancel the zeros and put 300 over 250. It still does the same thing. But just let the calculator crunch the numbers for you. And the third part, how long until there is 100 grams left? Now this is less than the 125, so we have to have an answer twice as big as 4,300, twice as big as 2,150, which is 4,300. We have to be bigger than that in years. So 100 is now going to be my P of T. So using this equation right here, putting 100 in for P of T, we'll solve this for T. So again, we got to get the base by itself, so we divide over 500. And again, in this case here, If you see it before you write it and you want to cancel those zeros and call it 1/5, by all means go ahead. Or if you want to write it as a decimal, 0.2, that's fine as well. I'm thinking because we're going to go to the calculator, it probably would be easier to type it in as a decimal. So we can change the 1/2 to 0.5. So we need to convert this to a log. So log base 1/2 of 0.2 is equal to our exponent, t over 2,150. So to solve for t, multiply the 2,150 over to our log, and now it's ready for the calculator. So 2,150 times log base 0.5. This is under the math button. All right, go scroll down until you see log base, and you'll get a text box and a text box in these two locations. Just enter the numbers, and we're at 4,992.15 years, which was bigger than that 4,300. All right, so that concludes section 6.7.